Hello, good morning, guys. So in the last class, we saw about like what is a network bit, what is host bit, subnet mask, okay, and we saw some examples for subnetting, right? Now, if we discuss about subnetting, your subnetting is of two types. Okay, subnetting is of two types. One is the classful subnetting, and second is the classless subnetting. Okay, and that was your task, right? So what is classful and what is classless? So subnetting, why we perform subnetting? To reduce the wastage of IP address so that we can assign the IP addresses economically. Okay, we don't waste a lot of addresses while using small number of addresses. So just to reduce the wastage of IP addresses, we perform the subnettings. Okay. Now we have two types of subnetting. One is the classful subnetting and classless subnetting. So first thing, let's come to the classful subnetting. So what is classful subnetting? That was your task to check about classful and classless or something else. Yes, that only, right? Yes. So what is classful? Did you guys check or not? First question. Checked. Okay. What is classful?
Classful subnetting are those subnet which are very thin /8, 16 and 24.
Correct.
And classless are if it is a classless, so it will vary in the class 16 or class 24. The subnet will be changed.
Okay. See, what is classful? Or when you say a particular subnet is a classful subnet, whenever you are using a default subnet mask. Anytime you are using a default subnet mask, like with the class A IP address, you are using /8. With the class B IP address, you are using /16. With the class C IP address, you are using /24. So that will be considered as classful. Okay. So in case of classful, we just perform default subnet mask, or we just use default subnet. So whenever default subnet mask is used, that is classful. Because how do you decide a class? How do you decide a class? By looking at the first octet, right? But the network part and host part, that will be given by, in class A, we say there are 8 network bits and 24 host bits. How that is done? Using the default subnet mask only. As soon as you change the subnet mask from default, that will become classless. Now we do not belong to any class. That totally becomes classless. Okay. So in case of classful, default subnet mask will be used. Okay. And in case of classless, subnetting, you will say anything other than default. Okay. And this classless subnetting, your classless subnetting is the one that is known as CIDR. CIDR stands for classless inter-domain routing. Okay. Means when we are not using the default subnet mask. Your CIDR stands for classless inter-domain routing.
Classless means that the slash notation.
Yeah, everywhere slash notation will be there. Everywhere we'll now use slash notation only. We'll not use the subnet mask like 255.255. Always with an IP address, CIDR notation will be given. Prefix length will be given.
Slash notation is classful subnet.
When you're using the default one like /8, /16, 24, that will be classful. Other than that, classless. Okay. Means not just /8. Like let's say if I'm giving one IP address, for example, 10.0.0.1/8. This is what? Classful. But if I go with 10. not 10, but let's say 172.16.0.1/8. Now, is it classful or classless? Classless. Why? Because IP address is class B and mask is different, not a default. So this will become classless. This thing is clear. Now, the kind of questions we get in the subnetting that we have seen yesterday, according to that, we'll make the calculations. See, all you are going to be asked in the questions will be either network ID, either broadcast address, or some IPs from the valid IP range. That is the part that will be asked inside the questions. Okay. Then let's say you have been given an IP address. For example, first of all, let's take class A example. Not class A, class B. For example, you have been given one address, let's say 10.11.12.13/8. Okay. Now from here, you came to know that, okay, according to /8, how many network bits we have? 8. How many host bits we'll have? 24. Correct. If you write the subnet mask according to this, how you're going to write? You're going to write 8 ones. Correct. And 24 zeros. This is your subnet mask. Now we know that inside the subnet mask, what will happen? Ones are the network and zeros are the host part. Host octet and network octet. That is clear. So from here, we came to know that, okay, first octet is what? Network, and remaining 3 octets, host. Okay. And if you want to calculate the subnet mask in decimal, this will be 255.0.0.0. Now you have the IP address. Now for this IP address, you have to write the range. Okay. You have to write the range. So how you will write the range? Which part we have to keep constant? Network part means the first octet. What is the first octet value? 10. Now remaining part, the first IP address will be minimum. So setting all 3 octets to minimum. 0.0.0. The next one will be right, and like this, the last IP address will be host part maximum, and last valid IP address. Clear? Okay. So this is how we have to make up the calculations. Okay. So this will be your network ID. This will be first valid IP. Then we'll have last valid IP. And finally, broadcast address. Now, if I say how many host bits are there? Total, how many host bits are there? So what will be the total number of IP addresses here? 2 raised to power 24. So either you can calculate like total number of hosts. That will be 2 raised to power 24. Now this total number of hosts is also known as block size. This is also known as block size. So block size is what? 2 raised to power 24. Okay. That will be 167.77.216. Okay. This is clear? Okay. One dot 2.3.4/8. Network ID, broadcast address. What is it? Just by looking at the IP address, we can tell. This is clear? Okay. So class A is easy, right? n dot 255, 255, 255, and this will be broadcast address. So if we say we have class B here, class B, classful, you have 172.16.1.2/16. Network bit 16, host bits 60. Then write the subnet mask. So 16 ones and 16 zeros. Correct? And if you write in decimal, so from here we came to know, okay, 2 octets are network, 2 octets are host. Then write the IP range here. What will be the IP range? Starting range 16.0.0. Next address, first valid IP 0.1. Then last address 255.255, 254. Correct. So first address, network ID. This will be network ID. You can write in short first valid IP, last valid IP, and broadcast address. See, you do not always have to write all these things, okay? When we are talking about questions, so we don't need to make all this calculation. We'll just see the IP address, and accordingly we'll just find out, okay, this is it, this is it. No need to write every time the subnet mask and everything. Okay. Let's say IP address given to you. Comma. Then network ID, broadcast address. It will be .17.0.0. Broadcast address 255.255. Okay. So Classful is easy. We have done yesterday, right? So this will be easy. Class C. First of all, tell me, is it a correct IP address? Is it class C and is it correct? Yes. Correct. Okay. Network ID. Sorry. Network bits
24.
20. Host bits 8. Subnet mask 'Why I'm writing this subnet mask in binary? Because sometimes you'll get confused with the decimal part, but binary will never confuse you. Okay. Because right now this is classful, so it looks easy. But in case of classless, there might be some confusion. So whenever you get confused, always check out with the binary. And if everything doubts, everything will be clear. 3 octets network, 1 octet host. Okay. So what will be the network ID? Dot 0. First address. Dot 1. Last address. Second last address. 25. And this will be network ID. First valid IP. Last valid IP. Broadcast IP. Is it a valid IP? Yes. Yes. Is it a valid IP address? Okay, one student is saying no. Yes. Everyone is saying yes. Are you sure? Why no?
254 is last, 255 is broadcast.
255 is a broadcast. Isn't it a broadcast? 4th octet maximum. 3 octets we have network, 1 octet host part maximum. That will be the broadcast address. So this is not a valid IP. Okay, this is an address, no doubt. This is a class C address, no doubt. But when we consider the range, this is not a valid IP. This is a reserved for broadcast. Okay. So let's go with the 254. Network ID, broadcast address. So what will be the network ID and broadcast address? 225.0. Broadcast 255. Correct. So Classful is clear. Classful you can do easy. Now let's move on to classless. Okay, classless will start from class C. Let's say class C classless. Now let's say you have been given an IP address 192.168.0.1. What is the default slash value? 24. This time instead of 24, I'll make it 25. Okay. Now tell me, what is the number of network bits? 24. 25. After the slash, what you write? Number of network bits. So number of network bits is 25. Then what is the number of host bits? 7. This is clear? Okay. Now if I write the subnet mask in binary. Correct? Now earlier it was, this is the default one. But now in the new subnet mask, this 1 bit we have changed. Okay. From host, we made it to network. Correct? Okay. So what will be the subnet mask here? New subnet mask? 255. 255. 255.128.128. Correct? Okay. So in case of Classful, how many bits we had here in the host? 7. Default 24. 8. In case of default subnet mask, we had 8 host bit. Correct? According to 8 host bit, if I want to calculate my block size, what would be my block size? 2 raised to power 8. Number of host bit, right? 2 raised to power 8. That means 256. So if I calculate my block size now, so in which octet I have host bits? 4th octet. So let me calculate 4th octet block size. 4th octet block size. So that will be calculated by 2 raised to power host bits. Correct? So my number of host bit is 7. So 2 raised to power 7. That means 128 addresses. So earlier when I was getting 256 addresses, my range was starting from 0 going till 255, because total how many addresses I had? 256. This time how many addresses I have? 128. So my addressing will start from 0 and go until 127. Right? Okay. So let's design our first network. 192, 160. Okay, from here if you calculate, see these 3 octets, these are purely network. Right? And the 4th octet is it has some part of network and some part of host. Right? This is where we have some part network, some part host. Okay. So whatever is the pure network, that has to remain constant, because network part is always going to remain constant. So 192.168.0, this part is constant. 168. This part is going to remain constant. Okay. Now, whenever there is a host part, what we do with it? Start from minimum. Start from minimum. Now, what is the maximum number of addresses I have here? 128. That means this range should end at 0.127. Correct? Okay. 0.1. Correct. And here 126. So whenever we decide, see, this is our one network. This is our one network. So for the first IP again, what is it? Network ID. The last IP, broadcast address. Then first valid IP. And then last valid IP. Correct? Okay. So from here we got the addresses 0 to 127. What happens to the rest of the addresses? If you see, total how many addresses I had in case of default? 256. Okay. And I got one part of 128. Still how many remaining? That means that is a different network. So when we are using /24, we were getting one network with 256 addresses. One class C network with 256 addresses. But when we went classless, when we borrowed one bit, it was broken down into 2 networks of 128 each. Okay. So how do you calculate that in how many networks it will be broken? So that part you can calculate using how many bits you borrowed. Okay. So if you want to calculate number of networks, okay, total number of networks, that you can calculate by 2 raised to power number of borrowed bits. How many bits we borrowed from the host part? Only 1 bit we borrowed. Earlier this was 0, now we created it 1. So only 1 bit we borrowed means how many networks will be designed? 2. So first network is from 0 to 127 and the second network will be, okay, let me just type it. So our second network will be starting from 128 because this is ending at 127. Okay. Then .0.129. Here we'll have, what will be the last address?
255.
255, correct? So this will be 192.168.0.255. And this will be 254. This thing is clear. So now we have two different networks. Okay, and both of these are two different networks, means they will not communicate with each other. Because if you want communication between two different networks, then what will happen? What you need? Router. Okay, this thing is clear. Now let's say the IP given to you is 192.168.0.1/25. This is the IP given to you. According to this IP, what will be the network ID? What will be the broadcast address? For this particular IP, what will be the network ID? What will be the broadcast address?
22.168.
Okay,
0.0.
0.0. Okay, what will be the broadcast address?
192.8.0.127.
127, because your IP is what? 0.1. So this is falling in this range, not in this range. For this range, we have different network ID and broadcast address. And for 128 to 255, we have different network ID and broadcast address. So here it will be 127. If your IP address was, let's say 192.168.0.200. Now this IP address is falling in the second range, right? So here your network ID would be 0.128, and your broadcast address would be, this is clear. What if the IP address is what will be the network ID and what will be the broadcast address?
One 193.194.
Hmm.
255.160.
Dot 160.
128.
128. Okay. Then
193.194.255.
clear. We just will see, okay, /25 means there are two ranges, 0 to 127 and 128 to 255. Now we'll just check what is the IP address here. 160 means falling in the second range. So for second range, network ID is 128, broadcast address is 255. Right? Okay. What if the IP address is
Zero.
11.12.13.0? 13 dot? Correct. Okay, this time we'll not get confused with 11. Why? Because as soon as we change the subnet mask, this is classless, not belonging to a class. Okay, so all the calculations in your subnetting will be according to your subnet mask. Do not focus on the IP address, that from which class it is belonging, where it is starting. No, we'll always focus subnet mask. According to the subnet mask, we'll check, okay, what is the network ID and broadcast address. This thing is clear? Okay. Not done.
Yeah, on doubt actually.
Yes, please.
If in case the class of subnet mossing is not only applicable for class C, it is not applicable for class A and B.
Can you repeat, please?
Actually, the classless subnetting mask is only applicable for class C.
No, it's applicable for all the classes A, B, and C.
Okay.
Yes.
Can you give us some example with some?
Yes, I'm coming to that. Right now, I'm class C, then we'll go to class B and then A as well.
Okay, fine.
Okay.
Sir, what happened if we divided 56 to four different networks?
Hmm?
If you want to divide it, we divided it to two different networks. What happened if we divided it into four different networks?
Yeah, we'll come to that next part. Still coming. See, the octet in which you will get network and host both, that octet will call it as an interesting octet, because that is the main octet where we are going to focus. And with that octet only, we'll make our all calculations. Okay.
So class B slash will remain similar.
Everything. This is class A.
Hmm.
See, right now when we go classless, that means no class. Doesn't matter what is the IP address. If the slash is this, calculation will remain same. Got it? Done. Okay. Let's take one more example. Class C, classless. Let's say 192.168.10 dot will have 70. 10.70. Last time we had 25. Let's go with 26. Let's try to borrow more bits. Okay. According to this, network bits 26, host bits 6. What will be the subnet mask? Yeah. How many bits we will borrow this time? 2 bits. So in decimal, what will be the subnet mask? 190. So again, first part is network, 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 and this is the interesting one, network and host. Correct? So again, if I want to calculate, let's say total number of networks. So what will be my total number of networks here? 2 power 2, that will be 4 because number of interesting or borrowed bits 2. So if I say total number of networks, that will be 2 power 2. This time 4 networks are going to be designed. Okay. See, this number of networks I'm calculating according to this IP address. Okay. Yes. Okay. So which octet block size I will calculate? 4, because 4th octet is my interesting octet. Right? So 4th octet block size. That will be 2 raised to power 6. What will be the size? 64. If it is 64, that means my first network again, see 3 octets I need to keep constant. Dot 10. This part I need to keep constant, right? Start from minimum 0. This is my first network ID. So I know how many networks will be designed? 4. So means my second network ID will start from, how do I calculate my second network ID? Whatever is your first network ID, in that network ID, add your block size. Okay. See which octet block size it is? Which? 4th octet. So in the 4th octet, just add this value. So your next network ID will be 10 dot. Again, next network ID will be correct. 10 dot 120. And again, next network ID will be 10 dot 190. This is how we came to know, okay, 4 network IDs. Okay. Now, first valid IPs. Why? Dot 1. This will be 65. This will be 129. And this will be 193. Okay. So what will be the last IP here?
63.
63. Why? Because my next network is starting at 64. So this will be 63. Here 127. Here 191. And this is my last network. That means maximum. This will be 62. Then 126. 190. And this one will be 254. We have network ID, first valid IP, last valid IP, and we have broadcast address. Correct. Okay, so according to this IP address, whatever IP address right now we have, so this is what 70/26. What will be the network ID? And what will be the broadcast address?
264
Dot 64 is the network ID, and 127 is the broadcast address. Okay, what if it is 172.173.174.175/26? Network ID and broadcast address. 128. Okay, 172.173.174. Let me copy this. Dot 128, and broadcast address will be 190. Clear? Okay. So now you know that, okay, you just have to focus on the interesting octet and the slash value, and accordingly everything will be calculated. Okay. So same way you can keep on borrowing like 26, 27, 28, 29, and 30. 31 and 32 we cannot use. Why? Because see, when you will be using 31, how many network bits will be there? 31 network bits. When you're using /31, 31 network bits will be there. How many host bits?
1.
1. That means your block size will be 2. 2 means only 2 IP addresses. So either you can use them as a network ID, broadcast address, first valid IP, last valid IP. Right? So either both will be reserved. So 31 is a special case. Yeah. Okay. About /31, if you are asked in interviews, /31 is a special case and it does not follow your subnetting rules. Okay. We can use /31, but only in the point-to-point networks where only 2 IPs are required. Okay. It will not follow your subnetting like if there is a need of network ID, there is a need of broadcast address. No, nothing like that. And /32, when you're using /32, how many network bits? All 32 network bits. How many host bits? 0. That means how many, what is the block size? 1, 2⁻0. That is 1. Means individual IP address you will get. So that you cannot use. Okay. So up to /30 you can go. 31 also we can use. I'll show you, but only in the point-to-point networks. Okay, we cannot use it in the other calculation like LAN environments and everything. We cannot use it. So for subnetting part, we'll go till 30 only. So 25 and 26 I have done. 27, 28, 29, 30, that is your task. Okay, to practice. Clear? Now next, let's move on to class B. Class B, classless. Let's say your IP address is 172.16.0.1. Okay. Default slash value is 16. Let's go with the 17. According to this network bits, 17. Okay. Host bits, 50. Correct. Subnet mask. How many borrowed bits? Only one. Okay, which is the interesting octet here? Third. Correct. So if I write the subnet mask 255.255, 128.0. That means I can say network, then my interesting octet, which is having network and host both, and then purely host. So now again, we need to focus on only one octet, third octet. Okay. Again, if I want to calculate total number of networks, 2 raised to power? Huh?
17.
Number of borrowed bits? 1. Right? That is only 2 networks. Because earlier class B, we were getting 1 network. Now we divided that network into how many networks? 2 networks. Okay. And third octet is our interesting octet. So I'll go with the third octet block size. So what will be my third octet block size? 2 raised to power host bit in the third octet. Right? So in the third octet, how many host bits I have? 7. See, follow the same approach. Just focus on the third octet or your interesting octet. Nowhere else to focus. Otherwise, you'll get confused. Okay. So if you go with the 2 raised to power 7, that is again 120. Now let's calculate. First part we need to keep constant. 172, 16. Now third octet having host and network both. So having host means start from 0. And fourth is purely host. Done. First network done. Second network we need to calculate. So how we will calculate? We'll add the block size in the octet. So in which octet we will add the block size? Third octet, because this is third octet block size. So this will be 172, 16, 128.0. Done. So if my second network is starting at 128.0, my first network will be ending at correct 127.255. Next IP will be 128.0. And since this is my last network, this will go till maximum. Okay. First valid IP 172.16.0.1. Here it will be 172.16.128.1. Here it will be 172.16.127.254. And here it will be 172.16.255.255. Yes.
172.16.127.
Where? 127.
172.16.127.
Hmm.
Is it 126?
Why 126? This is starting where? 128. So after 127.255, what will be the next IP? 128.0. If we will write 126, so means we will be missing one network, that is with the 127. See, 0 till 127, how many? 128. 0 till 127, 128. That is our block size. and 128 till 255, that will be another 120. Is that clear? Okay. Okay, if this is having confusion here, what we can do, we can test it. Okay, that will make it more clear. First valid IP. Last valid IP. And this is your broadcast address. See how to test it. So if I'm giving an IP, let's say 172.16.0.1. So according to our calculation, network ID is 0.0 and broadcast address is 255.2, 127.255, correct? So that means if I'm giving this IP and this subnet mask in my system, right? According to this, my broadcast address is. So that means I cannot use it. Let's test. Let's check. Okay, no need to get confused. Just practically we can perform it. See, I will use the IP 172.16.127.255, correct? And the subnet mask I'll use 255.255.128.0, correct? Error. What is the error? The combination of IP address and subnet mask is invalid because all of the bit in the host address portion of the IP address are set to 1. So when host part is maximum, that is what? Broadcast address. Okay. And 0 is your network ID. So if I use 0 in here, in this place, if I use 0.0, okay, that means it will say all host bits are 0. That means that is the network ID. Similar thing you can test with this 128.0 also. Now see, set to 0 means this is network ID. 255.255. Set to 1 means broadcast address. Okay, that is clear. Or still doubt? Yes, Nick. Yeah.
I don't understand the part of the block size.
This is our interesting octet. So this time we'll focus on this octet. So in this octet, how many host bits are there? 1, 2, 3, 4, 5, 6, 7. So 2 raised to power 7. See, there's another way. You can even go with another way. You can take all your host bits in consideration. You can go with, let's say, 2 raised to power 15. Why this is not working? See, if you take all the bits in consideration, let's say if you calculate total block size, okay, if we go with the total block size, what will happen? You will consider all the bits, host bits, so that will be 2 raised to power 15. So 2 raised to power 15 will be 32768. Correct. Now these many IP addresses you will get, but the problem is that okay, these many IP addresses, how you will start the range? First confusion. Okay. Then what you will do that okay, in one octet, how many? In one octet, how many? 0 to 255 maximum value. So that means 256 addresses we can accommodate. Divide with 256. That will tell you how many times you will change the third octet. Divide. If you divide, see here. So you will divide 32768 divide by 256. So that is the ultimate answer again you are going to get. Okay. So you do not get confused. That's why I gave you direct. Okay. Otherwise, in class A, we will be working in the second octet. That will even make you more confused. Okay. Now, according to the IP address 172.16.0.1/17, what is the network ID? What is the broadcast address? 0.0. Broadcast address. Correct. This is clear. Means doesn't matter what is the IP address. Accordingly, you can check. We will just always focus on the slash value, and that will give you the answer. See, I'll be sharing this print file, so no need to note down. Next example. Once again, we go with classless. IP address, let's say 172.16.12.55. Slash value, instead of going 17, 18, let me go with the, let's say 23. Because see, if we are using /24, we can go up till 30. Similarly, if you are using class B, then from 16 till 30. Class A, 8 till 30. Like this you can. Okay. Now see here. Number of network bits? 23. Number of host bits? 9. Subnet mask. Correct. This will be the subnet mask. Okay. This time, how many bits will be borrowed? These many bits. 255, 255, then 254.0. Network, and host, and purely host. Which is the interesting octet again? Third octet. If I go with 25, 26, 28, then interesting octet would be fourth octet. Okay. So according to interesting octet only, we will make the calculation. Here, if you say total number of networks, that will be 2 raised to power 7. That means 128. Correct. Now, I'm not going to mention all 128 networks here. Okay, I'll just mention first, second, and last. That's it. Third octet block size? 1 or 2? 2 raised to power 1. That is, this is the third octet block size. My first network would be 172, 16. Then these are the two network parts I need to keep constant. Then correct. Then next 2.0. Okay. What will be my last network? Whenever you want to calculate your last network, always check your subnet mask. What is the value in the subnet mask? What is that? 254. That is your last network. 172.16.254.6. That will be your last network. Okay. First IP 172.16.0.1. This will be 16.2.1. This will be 16.254.1. Okay. This network is ending at my second network starting at 2.0, right? This will be ending at 1.255. This will be ending at after 2, my next network will start at 4.0. So this will be 3.255. Then this is my last network. Dot 172.16.1.254. 172.16.3.254. 172.16.255.254. This is clear. Again, we'll have here, these are all network IDs. First valid IP, last valid IP, and this one is broadcast address. Okay, so your IP address is 172.16.12.55/23. What is the network ID? What is the broadcast address? Now there is confusion. See, in this kind of scenarios, what you're going to do? First network, what is the value here? 12. Okay. First network 0, second 2, 4, 6, 8, 10, 12, 40. Correct. These are the third values. 0, 2, 4, like that. What is the value here? 12. Do I have it in the network part? See, I'm writing here what network IDs. So these are my network IDs. Correct. So means ultimately my network ID will be 12.0. But this 12, after 12, what is my next network ID? 40. That means that's it. Okay. No need to write all the networks. Just focus on the what is the part here and how much is the block size. Accordingly, you'll get the answer. Okay. Any doubt in this? That how we got the network ID and broadcast address? 12.0, 13.25. Okay. Let's take one more example here. Let's say your IP address was 172.16.70. Okay, 70.255. Yeah, 255, no problem. 20. Simply, block size is 2. Will 70 come in the multiple of 2? Yes, it is going to come. So 70 and 71. That's it. So this will be 172.16.70.0. Broadcast will be correct. Any doubt in this part? Clear to everyone? Okay.
Ajay, actually, whatever network you are given, that is having the broadcast sector.
Actually, your voice is so low. We are not able.
Actually, whatever the IP is, right? 172.16.70.255, it is a broadcast IP, right?
No. It's not a broadcast IP. It is coming in this range. So this is a valid IP here.
Oh, okay, understood. Yeah.
Okay, because broadcast address is 71.255. So this will become a valid IP.
It's 69.255 is the broadcast.
Yes, 69.255 would be a broadcast.
Clear.
Now next is class A. So let's say IP address is 1.2.3.4 only. Instead of /8, let's go to /9. Okay. Number of network bits, 9. Number of host bits, 23. Subnet mask, this one will be borrowed. Correct. This will be 255.128.0.0. That means network, then interesting, then host and host. Okay, let's go with total number of networks. That will be 2 raised to power 1. 2 networks will be designed. Which octet block size? Second octet block size. That will be 2 raised to power 7. First IP 1. Correct. Next network will be
1.128.
correct. That means last IP 1.127. Correct. Okay. This will be 1.0.0.1. Here it will be. Correct. 1.127.255.254. What will be the value here? Correct. And last. Here. Network ID. First valid IP. Last valid IP. Broadcast address. Okay. So according to the IP address, network ID, and broadcast address. What is it? Correct. Correct. Okay, what if I go like this? Let's see. What if I go like this? Okay.
172. So 255.
This is clear to everyone. What you did, you just focused this part. According to this part, you came to know this part we need to keep constant and remaining 3 will change. Now, what is the interesting octet here? Second octet. Second octet means what is the value here? 170. This range or this range? Second range. So 128 and 255. Okay. Concept is clear. So let's take one more example for the class. Let's say you have an IP address 10.11.12.13/. 29. Okay. Network ID, network bits, 29. Host bits, 3. Okay. Subnet mask, then okay, this time we'll not calculate number of network that will be used, because we ultimately need network ID broadcast address only. So that will calculate using the block size. Okay, so no need of number of networks. So this will be 255.255.255 dot. What will be the value? 248. Okay, that means purely network, purely network, purely network, and then interesting octet. Correct? Okay. So according to this, 4th octet block size. Correct? Fourth octet block size. And that will be 2 raised to power 3. That means 8. Okay, which part we need to keep constant? This much part. 4th octet is having network and host both. Start from 0. First network ID. Second network ID. 10.11.12. Why 127? What is the block size? 8. So add the block size. 8 will be the next one. Again, what will be the next one? 16. Now, instead of calculating more, I will just check what is my IP here. This will come before this. My IP address will already come before this network, right? Okay. That means, let me just copy this. This will be 1, 9, 17. Second one starting at 8. That means ending at. Next one starting at 16. That means ending at 15. Okay, now I do not care about the third network also, because my IP is already there. I already got my network ID and broadcast address. 6. This is 40. So that means now this calculation also not required. We will just make the calculation as much as needed. Okay, no need to do entire calculation. First valid IP, last valid IP, and broadcast address. Okay, so for this particular IP address, what is the network ID? What is the broadcast address? 10.11.12.8. Broadcast address 12. This thing is clear. Okay. Now doesn't matter which class IP address. Okay. Okay, now I'll give you some examples and you guys tell me. Let's say the IP address is 21.22.23.24 and slash value is 25. Tell me the network ID and broadcast address. See, try not to use a pen and paper. That will be better.
23.0 and 23.0.
Okay, this will be. See, according to this, we came to know slash value is what? 25. More than 24, 4th octet will become your interesting one. Now, in 4th octet, how many hosts will be there? 7. 2 raised to power 7 will be 120. Means first network 0 to 127. Is it falling in that range? 0 to 127? Yes, that is your answer. 0, and this will be simple. Okay.
One 171.172.173.
See, this much part already we know constant, right?
Yes.
This much part we already know constant. Now here you can use pen and paper because you need to add some values. Okay. So we have see what is the value here? 184. So first network 0, then 16, then 32, then 48. After that 64. Then means multiple of 64 will be 64, 64, 128. 128, 64, 192. So means before 192, what will be the network ID? Subtract 16. 176. Okay. See how to get it. Your block size is what? 16, correct? Okay. First is 0, second is 16. Means we have to keep on adding 16. Adding 16 10 times. 160. Next one is 192. You already have it. Correct. 176 and 191.255. Keep on adding 16. 10 times you'll add 160. Next one will be 176. That 192. So you already have your answer here. Why? It is 184. So 184 will fall where? Between 176 and 180. Oh, sorry, my mistake. My mistake. Okay, this will be here 176, 171, 172, 173.191. Okay. This will be 176. This will be 171.172.173.191. This is clear. Okay. What if I give you 10.11.12.13/6? Network ID, broadcast address. This /6, this one is asked mostly in the interviews. And some students get confused and they say, this is not even possible. The first question, they'll give you the IP address with /6. They'll ask you, is it possible? And you'll say, okay, class C/8. That means not possible. No, it is possible. Okay. We do not care about the class. We do not care about the default subnet mask. We just care what is the / value given. Okay. And as long as we have a / value, we can calculate. Okay. So what will be the network ID? What will be the broadcast address here?
8.0.0.
8.0.0.0 and 11.255.255. Is that? Okay. See here. What is the / value given? 6. According to 6 means first octet. Okay. So first octet, your subnet mask will be this one, and remaining all 0, 0, 0. Right? So 6 ones, 2 zeros. What will be the value? Is it 252? Right? 0.0.0. Now, how many bits you have here? 2. 2 raised to power 2. What will be the block size? 4. So first is 0, 4, 8, 12. These are the network IDs and these are the first octet values because your interesting octet is first octet. Your value is what? 10. So that will start from 8 and at 11. So 8000 and 11 255 255 255. Okay. So no need to get scared of what is the slash value. Just make the calculation the way we know. Okay, we have seen the approach, we have seen the concept. So according to the concept, if you will make the calculations, you will never get wrong. Another thing, see what you can do. Let's say this IP address has been given to you, correct? And slash value is 6. Easy method. One is you make this calculation. Second, if you get confused in this method, always go with the binary. Binary will always give you the exact answer. How? What is my value here? 10. And I know which is my interesting octet. First octet. So according to subnet mask 1, 2, 3, 4, 5, 6. Correct? 0, 0, and remaining all are 0. So those who I do not care because I need network ID and broadcast address. For network ID, I'll keep the minimum, broadcast maximum. Now here, how many network bits? 6. So these 6 bits I will keep constant. So if I write my IP address in binary, the first octet in binary, this will be 0, 0, 0, 0, 1, 0, 1, 0. Correct? Now, how many bits I need to keep constant? 6 bits. These 6 bits I will not change. According to subnet mask, 6 bits are network. So in binary, I will not change these 6 bits. Remaining bits, if I set it to minimum, means all zeros. What is the value? Is it 8.0.0.0? Correct? And for broadcast address, what we'll do? We'll make it maximum. So these 6 bits I will not change. And remaining part, I will make it maximum. These will be all ones, all ones, all ones. Right? So 1, 2, 4, 8. So 8 plus 4 plus 1. Sorry, 8 plus 2 plus 1. Because 1, 1, 1. So 8 plus 2, 10, 1, 11. 11 dot. These are all one, all one, all one. 255, 255, 255. Both methods you can use, whichever is comfortable. But whenever you get confused in this method, always go with the binary. Okay. You just have to not change these values. Whatever bits you have for the network, that values you do not change. Remaining bits for network ID, set all to 0. For broadcast address, set all to 1. And then if you will calculate the decimal value, you will get the answer. Is that clear? Okay. So I think you want to practice subnetting. So test will not keep it today because today's part will also be included. Right? So is it fine if we take it tomorrow? I'll share the link in the group. But you guys have to promise not to cheat, okay? Because if you guys will be at home and I'll not know who is looking where. Okay. All right. Let's take one more example. Let's go with our 94 and slash value. Let's go with the 90. Network ID, broadcast address. See, slash value is which octet is your interesting octet? Third octet. How many host bit in the third octet? 16 plus 3 means 5. 5, 2 raised to power 5, block size. 32, right? 32. First is 0, second is 32, third is 64, fourth is 96. Correct? 32, 64, 96. That means 64 is the network ID, 95.255 is your broadcast address. 91.92.64.0. Then 91.92.95.255. Because according to the third octet, Your block size came 32. First is 0, 32, 64. 64 plus 32, 96. So next network is starting 96. This will end at 95.255. So 64.0 and 95.255. And what is the value we are checking? Third value. Why? Because interesting octet is third octet. Is that clear? Okay. Let's say subnet mask is 255.248.0.0. What will be the slash notation for this? Hmm. Need to check, huh? Slash 13. Okay, 13.
And 13.
13. Why doubtful? See, you have to remember those values. That's why I gave you all those values. Right? To convert from decimal to binary, binary to decimal. Okay. All you have to remember just numbering. Let's say if you are not using all the bits are 0, 0. Then one single bit is 1, 128. Then 2 bits are 1, 192. 3 bits are 1, 224. 4 bits are 1, 240. 5 bits are 1, 248. 6 bits are 1, 252. 7 bits are 1. All bits are 1. Okay. This is all zeros. Now this one. Okay, like this, we keep on increasing. So you have to remember these values. Even these kind of questions are there. Okay. What if the slash value is 17? What is the subnet mask? 255, 128.0 because 8 plus 8, 16, only one bit extra. Right. What if your subnet mask is 255.255 dot slash value? Hmm? 20? 20, 20. 20? Correct. 8 plus 8 plus 4. 16 plus 4, 20. What if it is 3 slash 3? 2 to 4? No. Yes, only 3. 7. Okay.
224.0.0.0.
224.0.0.0. This is correct. 128 plus 192 plus, sorry, 128, 64, 32. Write this subnet mask. 3 network bit remaining on all host bit. All ones on the left. All zeros on the right. Okay. What about 255.248.0.255? What is the slash bar? Hmm? Not a valid subnet mask. Why? All ones should be on the left, all zeros should be on the right. So 0 will never come in between. But still some people got confused, I guess. No? Or you always remember? Remember? This is incorrect subnet mask. Okay. So classful, classless, any doubt subnetting? Easy, right? Okay. Let's go on the internet and check out some questions. Subnetting questions. Okay. So the first question is, your router has the following IP address on Ethernet 0, 172.16.2.1/3. Now do not focus on the language. We just focus on the what is given to us. Which of the following can be valid host ID? Okay. They are just asking valid host ID from this network. This is the IP and asking valid. Okay. 2.1/23/23. Which octet is the interesting octet? Third. How many host bits? Only one. Right? That means 2 raised to power 1. What will be our block size of the third octet? 2. Okay. All right. That means first is 0 in the third octet. Second is 2. Correct. Third is 4. Now which range they are talking about? 2. Means 2 to 3.255. Right? So 2.255 is a valid IP. Because 2.0 is network, 3.255 is broadcast. 2.255 is what? What about 3.0?
Yes.
Valid IP because 3.255 is the broadcast. So these two are the correct answer. That means option C. Okay. Let's check. Correct. Okay. Next question. Which two statements describe the IP address 10.16.3.65/23? Okay, read that. The subnet address. Subnet address means network IP. Okay. Is 10.16.3.0/ and the subnet mask is 255. So for /23, is the subnet mask correct? Yes or no?
Yes, sir.
And even you can verify everywhere they have given the same subnet mask. That means subnet mask is correct. Then second is, we need to check whether the network ID is this. Again /23. Just go to the previous calculation. Okay. 0, 2, 4. Address is what? 3.65. Okay, that means according to this address, network ID should be 2.0. Okay, means first statement is not correct. The lowest host address means first valid IP in the subnet is 10.16.2.1. After 2.0, will it be 2.1? Yes, first valid IP, this one is correct. Last valid IP, 2.254, is it? No. 3.255 means this one. So means second option is correct and fourth option is correct. Correct. Okay. Now here two systems are given. A network admin is connecting host A and B directly through their Ethernet, and these are all the IP addresses. The question is, what can be done to provide connectivity between the host? Okay. Because they are trying to ping and ping are unsuccessful. Now, this is not related to subnetting, but okay, still let's check. 1.20, 1.201. Are they in the same network? First of all, let's decide that. Yes or no? Are they in the same subnet?
Yes, sir.
Yes. How?
Subnet mask is same. in both.
So subnet mask same means same network.
Yes.
No. What will be the block size according to the subnet mask? 32, 16, 4 host bit. According to this subnet mask, 4th octet is the interesting octet. 240 means 4 ones and 4 zeros. That means multiple of 16 is required. First is network ID is 0, second is 16, then 32. Now already 20 and 201 completely 2 different networks. So without 2 routers, they cannot communicate. Then what can be done? Crossover cable? No. Crossover cable will not provide communication because again 2 different network. Rollover cable is your console cable, that will also not provide the communication. A default gateway needs to be set on each host. Yes, they will require a default gateway, but again we do not have a router, so we do not care. Subnet, so this is also wrong, this is also wrong, this is also wrong. Subnet mask should be set to 255.255.255.0, or the subnet mask should be set to 255.255.255.192. Now these are the 2 options. Looks interesting. 192 means 2 ones, 6 zeros. Correct. According to this, block size will be 64, 2 raised to power 6, 64. Again, not in the same range. So this option is also incorrect. Then subnet mask should be 255.255.255.0/24. That means 256 will be in the one network, 0 till 255. Then they will communicate because they will become in the same network. If you change the subnet mask to this, both will change into /24 and they will communicate. So option 5 is correct. But they are saying, okay, not a single option 5 is there. 1 and 5. Okay, crossover cable for the communication between same type of devices. Okay, so these 2 options will be correct because same devices means crossover cable. Okay. So this option will be correct. Okay. Is that clear? So this is how you have to practice. And also I'll be sharing some questions in your drive. There you can practice. Okay, let me do it right away. Okay, so there are 2 files. One is the notepad and second is the PDF. So practice these questions, and then tomorrow I'll share the link for the test and we'll have the test. Okay. So any doubt with the classful and classless subnetting? No? Yes. Clear to everyone? Online people?
Yes, sir.
Clear?
Yeah.
All right. Okay, then today we'll wind up.
So the test will be on Monday, no, sir?
Tomorrow, is it fine?
Tomorrow.
Yes, or if you want weekend to practice, then you can take weekend. We can have on Monday also, no problem.
Okay, no issue. Tomorrow.
Okay.
Same time.
I'll just share the link. You can take it anytime. This will be a 30 minutes test.
Okay. Okay.
All right. Okay, then I'll stop the recording.